Hi, my name is Kelli Matthews, and I am the Director of Communications for the National Research Consortium at Innovation Point Labs. We are a meta research lab that focuses on technology to market research initiatives. And so I'm going to visit with you today about produced water recycling and reuse impacts on the hydrologic cycle. We are currently part of a collaborative effort seeking an NSF IUCRC designation, and we are bringing to the table our Clary Advanced Resource Recovery site, and that is an oil and gas pad site where we look at energy, water, power, atmosphere, and a digital platform. Our collaborative partners, our corporate collaborative partners, are White Star Petroleum, Chesapeake, AECOM, Siemens, and Pitney Bowes. And our IUCRC team is obviously NRC, the University of Wyoming Center for Excellence in Produced Water Management, the University of Colorado at Boulder and their Renewable and Sustainable Energy Institute, RACE, OSU, the Boone Pickens School of Geology, and we are kind of having an ever-expanding relationship with NREL. So I hope you guys are ready to look at some data and talk data with me. So let's look at water stress in the oil and gas sector. We are seeing significant levels of water stress in different regions across the country, and our collaborative research partners through the Nicholas School of Environment at Duke have recently published a study looking at the intensification of the water footprint in hydraulic fracturing. What we're seeing is a water per well increase of up to 770% between 2011 and 2016. The flowback and produced water volumes for first-year production have increased by 1,440%. And we're seeing ubiquitous raises across all shale basins, with Permian being at the high end of that and the Marcellus being at the low end. But all of this is happening in the context of rapidly diminishing global water resources. So NASA and their GRACE recovery and their GRACE mission and their GRACE follow-on mission have partnered with JPL at Caltech to look at emerging trends in global freshwater availability. And this was published, I don't know if you can see that, but in May of 2018. And they quantified 34 regional trends in terrestrial water storage from 2002 to 2016, with the factors being water management practices, climate change, and natural climate cycles. The outcomes from one section of that show that drought plus groundwater withdrawals from 2002 to 2014 equals 4 gigatons of annual freshwater loss in Southern California. And if my Okie math serves me right, that's something like 43 Lake Hefners annually in freshwater loss. It's pretty substantial. And so the GRACE follow-on satellite mission imagery shows us the changes in cumulative water storage changes, and this is the Southern California region. And if you overlay that into what's happening in the fires in this region, it kind of makes sense. So we're seeing a deterioration in water storage in the form of ice sheets and glaciers, sea level, and solid earth. So we have some data sets here that are telling us the oil and gas sector is going to be facing significant changes here. But what do we do with these data sets? So we're going to go meta. We at NRC are creating an AI and advanced analytics platform to structure the data that's coming in and these data sets in ways that tell a story, that tell a complete story, so that stakeholders involved in these decisions can know how to navigate the future. And if you look at what we see here, is this is the model we are going to be adapting for the produced water space. So this is the Atlas of Economic Complexity that was created by Harvard and MIT, and we're partnering with them to do this for the produced water space. So each of these icons down below represents a data input point, and we are going to be doing this using data inputs from water profiles. So we're looking at the VOCs, existing infrastructure, how we're going to power this in a renewable and sustainable way, resource valuation, asset valuation. We're going to be looking at market analysis here too. And data is critically important. If you look at all of the data that's ever been generated, 90% of that has been generated in the past 2 years. So it behooves all of us to be able to look at this data and structure it in ways that is telling a story that's relevant to all stakeholders. So before I wrap up, I just want to take time to say we do partner with Oklahoma on many different levels. We're so proud to have worked with the Governor's Office and the Secretary of Energy and Environment, OWRB, Oklahoma Department of Environmental Quality, OCA Institute, the Groundwater Protection Council, and the Produced Water the Resource Working Group, and the Environmental Defense Fund. I look forward to speaking with any of you all who are interested in learning more about what it is we do at NRC. Thank you.